In the previous lecture, we looked into printing these kinds of patterns on the screen using nested loops. So here we are printing the X pattern of size 7. We are essentially printing a square on the screen of 7 by 7 square. So the idea was we write a outer loop, the rows that go from 1 to n and increasing the row number at each iteration. So R is walking over these numbers. And we have an inner loop where the column is going from 1 to n, so from 1 to 7 in this example, printing one row of this pattern on the screen. So at each iteration of the inner loop, we are printing one character of this row that we are printing. So the idea was, how do we determine what is the condition for printing a star character and what is the condition for printing a white space character, right? And that was this if statement. So if R is equal to C, which is this diagonal, or R plus C is equal to n plus 1, which is this diagonal. So if one of these conditions hold, we print a star character. Otherwise, we print a white space character. So we're essentially printing a square, 7 by 7 square on the screen. What if we want to extend this code so that we can print multiple of these patterns side by side? So in this example, we are printing 3x patterns side by side. So how can we extend the previous code to make this possible? As you can see, we have to print the first row of each pattern before we can take the cursor from here to the beginning of the next line. So remember, our inner loop used to print only one line, one row of a pattern. That means after the inner loop terminates, we need to again run the inner loop again for the second pattern, then run the inner loop again for the third pattern. So here's how we can do it. What we do is we put now an extra loop in between the outer loop and the inner loop. Remember, our innermost loop prints just one row of each pattern, right? One row of a pattern. And the outermost loop is responsible for walking over each row. So this is going to be the same, the outermost loop. The innermost loop will now still be the same because we're printing one row of each pattern. Now we add this extra for loop in between the outermost loop and the innermost for loop. So this is a triply nested for loop now. That's walking over the pattern. So it starts at pattern number 1 and it goes up to number of patterns. So in this example, we are printing 3 such patterns. So let's think about it. Let's forget about the outermost loop. Assume that row is equal to 1. So what are these innermost 2 for loops doing? So we are basically saying for pattern 1, so for the first pattern, go and print the first row, and this is what the innermost loop is doing. So basically, innermost loop is now column is going to go from 1 to n and print the first row of the first pattern. Then we are going to come back to the this for loop and increment the number of patterns. So pattern number is now 2, and we are now going inside the inner loop and saying for the second pattern, print the first row. For this pattern, where the C is now going over these red numbers, right? It's again from 1 to 7, but now we are walking over these red numbers in a sense and printing the first row of the second pattern. When we are done, we come back and increment the pattern number. Since we are supposed to print 3 patterns, now pattern becomes 3, number of patterns is 3. So we again go inside and print the first row of the third pattern. So we are now printing the first row of this pattern where the C is now walking over these blue numbers, right? C is again going from 1 to n, but now basically in a sense walking over these blue numbers. When we are done, we have basically printed out the first row of each pattern. So now we are done because the pattern, when we come back and increase the pattern, it will be 4 because we are printing only 3 patterns. This outer loop is going to be, in a sense, the second for loop is going to terminate. We come back. Now we move the cursor to the beginning of the next line because we are done printing the first row of each pattern. So the cursor needs to move to the beginning of the second row. We come back and increment the row number, and now we say, okay, for every pattern out there, print the second row, and then the third row, and then the fourth row, and eventually we are going to print the 7th and final row of each pattern, and we are going to terminate. This is example 25. Here is the actual code, example 25.cpp. Let me go into debug mode and print one row of each pattern. So we come here, the pattern is 1, the number of patterns is 3. I'm assuming that n is equal to 5. So let's print the first row of the first pattern. So column is now going from 1 to 5. So let's go in, print, this is the second iteration, this is the third, this is the fourth, and this is the fifth. Now we have printed one row of the first pattern. So as you can see, this is the first row of the first pattern. Now we increment the pattern count, and now we're going to come in and print this first row of the second pattern. And so we have to iterate 5 times, and you can see that after 5 iterations, we have now printed the first row of the second pattern, and we're going to do the same thing. So now do the first row of the third pattern, and here we go. So we are done, as you can see. So as you can see, we have printed the first row of the first pattern, first row of the second pattern, first row of the third pattern. Now cursor is at the end of the line. Before moving on and printing the second line of every pattern, we need to move the cursor to the beginning of the next line. And that's what we do by this cout statement, by printing out the end L and lines character that moves the cursor to the beginning of the next line, as you can see in here. Now increment the row number and repeat the same thing. So these inner two for loops, as you can see in here, these inner two for loops print the one row of each pattern, right? That's why this is iterating from pattern number 1 up until pattern number of patterns, and the innermost loop just prints one row of each pattern. So I'm not gonna continue, basically run it to the end so that you can see what gets printed on the screen. Actually, I should probably remove the. So let me do this. Let me remove the breakpoint and then run so that it runs to the end. And here you go. So this is the first pattern, a 5 by 5 X pattern. This is the second pattern, and this is the third pattern. So this is how you're supposed to do it. So if you're supposed to increase the number of patterns to print side by side, you put an extra for loop in between the outer loop and the inner loop. So remember, the outer loop is responsible for printing each row, and the inner loop is responsible for printing one row of a pattern. Let's now do the same thing for this pattern. So we are basically repeating this greater than symbol 3 times on the screen, side by side. So we are going to exactly do the same thing. So first, write the code to print one of these patterns on the screen, right? Remember, this was only half of the X pattern. So this was half of the X pattern. So row going from 1 to n, innermost loop going from column going from 1 to n plus 1 over 2. Remember, the number of columns for this greater than symbol was n plus 1 over 2. And the idea was exactly the same. So we are basically printing the X symbol, but half of it. Now, in order to duplicate this pattern, all we do is we put an extra for loop in between the outer loop and the inner loop. Now the pattern is going from 1 to the number of patterns. Of course, the number of patterns in this example is 3. That's why it's just repeating the same pattern 3 times side by side. This is example 26, and that's this pattern. So let me increment the number of patterns so that you see it's not only 5, it could be any number of patterns. So number of patterns is equal to 5. That means we are going to repeat the same pattern 5 times side by side. So this is the first pattern, second, third, fourth, and fifth. Our next example is to print L patterns, but repeat it multiple times. When you encounter a problem like this, always ask yourself, how can I print one of these patterns on the screen, right? So first write the code to print a single L pattern on the screen. As you can see, this is quite simple. This is a 5 by 5 in this example, it's an m by n square. What we're doing is, if the column number is equal to 1, we print a star character. Or if the row number is equal to 5, which is n, then we print a star character. Otherwise, we print white space characters. So that's just one pattern, one L pattern. And between each L pattern, we have a white space. So that we have to also take that into consideration, right? And then we're just repeating it afterwards. So let's write the code first for printing only one of these patterns on the screen. So R going from 1 to n, column is going from 1 to n. The condition for printing a star character in the L shape is if the column number is equal to 1 or if the row number is equal to n. Otherwise, we print a white space character. So let me run this thing so that you see we get a 5 by 5 L pattern on the screen. This is just one pattern. All right, so this is just one L pattern on the screen. What we are asked in this question is we need to repeat this pattern multiple times. And what are we doing? Remember, the way to multiply the pattern side by side is to put an extra for loop in here. So it's going to say number of pattern, the pattern number, the pattern going from 1, pattern is less than or equal to number of patterns, right? So number of patterns, which is 3 in this example, and we are incrementing the pattern numbers. And we now have to make this an inner loop. And in this example, we need to put an extra white space character in between the L characters. So let me first run this thing so that you see that it works, but there won't be any extra white space characters between these patterns. So let me run this thing so that you see the 3 L patterns appear on the screen, but there won't be, see, this is the first L pattern, right? And this is the second one. It's actually starting in here and going up until here. And this is the last row of the third pattern, third L pattern. What we want is we would like to have one space character between each pattern. To do that, let's go back to our loop. Let's think about it. This is just printing one row of a pattern on the screen. So that means before we move on and print the same row of the next pattern, we need to put an extra white space character, right? So that's all we need to do. So if you put an extra white space character, remember this inner loop is just printing one row of a pattern. So after one row of a pattern is printed, we just need to put an extra white space character so that the next pattern starts at at the one space later from the previous pattern. That's all you need to do. Just put that extra space in there, and now you're going to see that there's this white space in between each of these patterns. So it's quite simple in that sense to write these kinds of codes. Concentrate on just printing one pattern on the screen, and then add this extra for loop in between the outer loop and the inner loop to duplicate the pattern that's to be printed on the screen. Before we finish our discussion on looping constructs, here is one last example. Let's assume that you are given a positive integer. You are asked to reverse its digits. So if the input is 2, 5, 4, 3, when you reverse the digits, you get 3, 4, 5, 2. So 3, 4, 5, 2 is the answer. And the idea is you initialize a running number, let's call it reverse number, initialized to 0, while the number is greater than or equal to 0. So this is the number, 2, 5, 4, 3. What you need to do is you get the last digit. So last digit is equal to number modulo 10. Then you divide the number by 10, so to get rid of that last digit. So the number becomes 245. And reverse digit now becomes reverse digit times 10 plus the last digit. And as you do this, after 4 iterations, this number will become 0. The number will be 0. And reverse number will be 3, 4, 5, 2. This is example 28. Let me go to that example. This is 28. I'm going to ask the user to enter a positive integer, print it on the screen. Then I'm going to say reverse number is equal to 0, while number is greater than equal to 0. Process this number one digit at a time, and then compute the reverse number. And eventually, I'm going to print the reverse number on the screen. So let's take any number. So let's do 3, 4, 5, 2, 6. When you reverse it, you should get 6, 2, 5, 3, 4, and that's exactly what we are getting. The reason I solve this problem is this is one of the LeetCode problems. So this is LeetCode number 7, reverse integer. And the question says, given a signed 32-bit integer x, return x with its digits reversed. Of course, one thing you need to pay attention to when solving this problem is if reversing x causes the value to go outside the signed 32-bit integer range, then return 0. Because think about it, if the number is very big, when you reverse the digits, the number is it possible that the reverse number does not fit into a 32-bit integer. So you're also asked to pay attention into that detail. Also, that in this question the number could be negative. So you also have to consider the case when the number is negative. I'm not going to solve this problem. I'm just leaving it as an exercise. And the reason I mentioned this is, as you can see, this reverse integer is a technical interview question that you might encounter later on when you get into technical interviews.